Okay, greetings to everyone. Next, we should move on to another problems which are related to welded connections. So, in the previous problem, we have discussed that how to calculate the length of weld for the angle section. Okay, that is length of weld at the top and the length of weld at the bottom. Okay, now those two we have seen. Okay, now in the same way, if we are going to do in the three side, which means here with respect to plan section I am telling, so this is gusset plate and this is our angle. Okay, so if earlier we have seen here as well as here we have done the weld, so along with that if we are going to do weld here also, then how to calculate the weld length, that we are going to discuss in this problem. Okay, let us move on to the problem. So first I will write down the given data. The same previous problem. Okay, that is design the fillet welds for the angle section, ISA 80 by 50 by 8 mm. Okay, uh, the thickness of gusset plate is 12 mm. Design the welded connection. If the welds is to be done on its three sides. Okay, so let us move on to the problem. So solution, let us move on to the solution. So first of all, as we already said, first we have to calculate the design strength. So here there is no load, so first we have to calculate the design strength. It is design tensile strength of the member or section. Okay, so from IS 800, the formula is becomes TDG is equal to AN into Fi by gamma m naught, whereas gamma m naught value is equal to 1.10 from table 5 of IS 800 2007, and Fi value is 250 Newton per mm square. Next, AN value we have to calculate from the IS handbook. Okay, so for this 978 mm squared, I think 978 mm squared, and the CZ value also we have to calculate, that is 27.3 mm. So these are all the things which we are going to take it out from the IS handbook. Okay, Indian Standard Handbook. Now let us move on to the problem again. Okay, solution. Therefore, TDG is equal to AN 978 into Fi value is 250 divided by 1.1. If we are going to substitute, we can get 222.27 kilonewton. Okay. Now what we have to do it, we have to calculate the design strength, which means we have to calculate the length of the weld. Okay, so we already said that. So here it is a gusset plate, and here we connected the angle section. So here we are going to do the weld, and here we are going to do the weld. This is our CG section 27.3. Next here also we have to do the weld. So all the three sides. So earlier it was L1 and L2. Now along with that this also. So the total height of the IS angle section is 80 mm. Therefore, the total length of weld is equal to 80 mm plus length of weld at one side plus length of weld at another side. Okay. Now we should calculate the length of weld per pitch length. Sorry, per mm length. Therefore, strength of weld per mm length. So PDW is equal to LW into TE into FU by root 3 into gamma MW. Whereas gamma MW is equal to 1.25. Okay, from table number, sorry, here it is site fabrication. Okay, so if it is site fabrication, we have to use 1.5 as the value. 1.5 from table 5 of IS 800 2007. Okay, next TE. So if we need TE, we need size of weld. So we all know that K factor value is 0.7 and size of weld for 12 mm thick plate is 5 mm. That is from table 21 of IS 800. Okay. So if I'm going to substitute this, I can get 3.5 mm as throat thickness. Okay. So here per mm length, so LW is equal to 1 mm. Therefore, PDW, that is strength of weld per mm length, is equal to 1 into 3.5 into 410 divided by root 3 into gamma MW 1.25. So 3.5 into 410 divided by root 3 into 1.25. So 662. So PDW is equal to 662.79 Newton per mm. So this is the length of, sorry, strength of weld per mm length. Now what we are going to do, we are going to equate, that is the total load we know that is 222.27 kilonewton is acting. Okay, which is nothing but 222.27 into 10 cube Newton. So now we are going to equate the strength. So this load is going to act at the centroid. So 222.27 into 10 cube Newton is going to act here at the centroid. Okay, na? So now we are going to calculate. So this is LW1. So I'm just drawing the plan view. So this is the gusset plate. So here we have angle. Okay. Now I will change the color. And here also I'm having length of weld. Okay. So I'm going to take, this is LW1 and this is LW2. Okay. And here also I'm having in this side, that is nothing but this side, this one. Okay. So this is 80 mm. So here the centroid is going to act here. Okay. So at the centroid we can have the force of 222.27 kilonewton. Now we are going to equate these forces at this side. which means we are going to equate the moment with respect to this position. Okay, so what are all the forces we are going to have? Okay, so here we can have this length of there is, the strength of weld per mm length multiplied with LW1. Okay, that is one thing. Another one is the strength of weld multiplied with this distance. Okay, now it is going to have moment here. Okay, now then next, which is equal to the total load. Okay, we are going to equate that right now. So now we should move on to the solution again. Now let us move on to the problem. So I already said, now we are going to equate the all the forces. So first one, that is PW1 662.79 into that is uh, equating the moment about here. This is bottom of the section, about bottom of the angle. Okay, so first forces, here we can have the strength of weld per mm length. So 662.79 into LW1 into the distance is 80 mm. So this is in terms of Newton per mm. This is in mm. So it becomes a force. So force into distance, we will get a moment. Okay. So the distance, we are going to equate the moment up to here. So the distance is 80 plus. Next, here another length of weld is available. So which is nothing but 662.79 into, okay, the distance is 80 mm from here to here. 80 mm. Okay, then multiplying with 80 divided by 2. That is force into distance by 2, which is equal to, so equating to total force. Okay, which is equal to triple 2.27 into 10 cube. Okay, into this force into here. What is the distance? 80 minus 27.3. 80 minus 27.3. So force into distance. So by equating this, we can get LW1 value. Let us substitute and get it. Okay. So triple 2.27 So we are getting LW1 is equal to 180.91. So 180.91, we are going to say 181 mm LW1. So next we need LW2. So for that we know the formula, that is LW1 plus LW2 into 662.79 is equal to, that is equating the forces. Okay, triple 2.27 into 10 10Q. Okay. So LW1, we know the value of 181. LW2, we have to calculate into 662.79 is equal to 222.27 into 10 cube. So while solving this, we can get the value of LW2. That is, so 154.36 mm. We can say 155 mm. Okay. So LW1 is equal to 181 mm and LW2 is equal to 155 mm. Then this height of 80 mm. So the total length of weld LW is equal to 155 plus 80 plus 181. So 181 plus 80 plus 155. 416 mm. So this is the answer. So if they are asking, we have to calculate the length of weld. All the three sides means we have to equate the forces. That is, equate the moments with respect to one place, so that we can get the value of LW1 and LW2 and another side. Another side, we are going to take the breadth of the section. That is, breadth of the section, or else the web length of the section. Okay. So this is the way we have to calculate the, or we have to design the length of weld if they ask for all the three sides. Okay, sorry, in this problem, I have made one mistake. So here the total length of weld, okay, is going to change. So I forgot to add that 80 mm length. Okay. So here I have done, but in that position I didn't. Okay. So let us do it once again. So LW1 plus LW2 plus 80 mm. That is the total length of weld into 662.79 is equal to 222.27 into 10 cube. So LW1 value is 181 plus LW2 we have to calculate plus 80 into 662.79 is equal to 222.27 into 10 cube. Now substitute all these values so that we can get the value of LW2. Okay, 222.27 exponential power 3 divided by 662.79. It becomes 335, okay, 0.355 minus 181 minus 80. So that's 74.3 mm we can get, 74.3, approximately 75 mm. So length of LW1 is equal to 181 mm and LW2 is equal to 75 mm. Okay. And this side 80 mm. So the total length of weld LW becomes 181 plus 75 plus 80 mm. 181 plus 75 plus 80. 336 mm is the answer. Total length of weld. Sorry for the inconvenience. This one I forgot to tell while doing that. Okay, so this is the correct answer. Thank you all. So we should move on to the next problem. So next we should move on to another problem. So as like our previous problem, if the double angles are placed, so the double angles are placed means this is our cassette plate. Okay, here one angle has been placed and here another angle has been placed. This is called a double angle. That is, the angle, two angles has been placed back to back. Okay. If it is like this, then what is the length of weld that we have to calculate? Here the thing is the length of weld won't change. That is LW1 and LW2 is as usual. Here and here we are going to place. But the thing is the total length is divided into two times. Since here also we are going to do the weld and here also we are going to do the weld. That's why the total length has been divided by 2. So one side, one length, sorry, one for one angle, the total length becomes LW divided by 2. That we are going to use it. Okay. Let us move on to the problem for ease of understanding. So the given data, a time number of consists of double angle section, each 80 mm by 80 mm by 8 mm, welded on the opposite side of a 12 mm thick gusset plate. 12 mm thick gusset plate. Design the fillet weld. Design the fillet weld for making the connection in the workshop. So here they mentioned that workshop, that is shop welding. So gamma MW value is 1.25 from table number 5 of IS 800 2007. Okay. The factored tensile force in the member is 300 kilonewton. So this is the given data with respect to the problem. So let us move on to the solution. So before that, for understanding, I am going to draw a section. So this is the gusset plate of thickness 12 mm. And here they have placed the angle back to back. So the angle is 80 mm by 80 mm by thickness 8 mm. And they have mentioned that 12 mm thick gusset plate. Okay. The load is acting as P is equal to 300 kilonewton. Okay. Now we have to find out what is the length of weld. Okay. So let us move on to the calculation part right now. So first, we have to calculate the uh, uh, size of weld. So size of weld. So from IS 800 2007, the size of weld. Okay, now for that there are two plates. One is 8 angle section thickness. Another one is gusset plate is 12 Among them, 12 is the maximum. So the 12 is lies in 10 to 20 between. Okay, now so that size of minimum size of weld is equal to 5 Okay, this will be available in table number 21. So now size of weld is equal to 5 from table 21 of IS 800. Okay. Therefore, throat thickness TE is equal to 0.7 times of 5 If I'm going to solve this, I can get 3.5 is the throat thickness. Now we have to calculate the pitch length. That is now we have to calculate the strength of weld per length. So PDW is equal to LW into TE into FU by root 3 into gamma MW. Whereas gamma MW for sharp weld is equal to 1.25 from table 5 of IS 800. Okay. Next, FU value is 410 Newton per mm square. So length of weld, we are going to take it as a 1 mm since it is per mm length. Okay. Next, we have to go for T. So T is equal to 3.5 mm. So if we are going to substitute this, the length strength of weld per pitch we can get it as a 662.79. 662.79 Newton per mm. Now, the total length of weld. So here I am going to do the weld and here I am going to do the weld. Similarly, here I am going to do the weld and here I am going to do the weld. Okay, now. So now I need the center of gravity of the section, CG position of the given section. That is CZZ. So from the handbook, so IS 80 equal angle, okay, rolled steel equal angle. So 80 by 80 by 8 So the area is 1221 and the CG value CXX is equal to 2.27. That is 22.7. So 22.7. So total 22.7 mm. So the total length of weld is equal to L1, LW1 plus LW2 into 2 times. So since here I am having and here also I am having. Okay. Now equating to get the length of weld. Okay. Equating the forces. So equating the forces to get total length of weld. So here LW1 plus LW2 into 2 into 662.79 is equal to the total load they have given us 300 kilonewton. So 300 into 10 cube. Okay. So if I'm going to find either LW1 or LW2, then automatically while substituting in this equation, I can get. So for getting either LW1 or LW2, I'm going to take the moment about any one of the place. Okay. For the only one section. Okay. Let us move on to that. So consider only one position. This is CG position 22.7, and here we are going to have length. So this is LW1 I'm going to take. This is LW2 I'm going to take. So here the net tensile force 300 kilonewton is active. So the moment distance, the corresponding distance is 80 minus 22.7. 80 minus 22.7 becomes 57.3. So 57.3 mm. Now equating the moment with respect to here. Okay, now bottom of angle section. Okay, so that what is the force here? 662.79 into LW1 into 80. Okay, into 80. So here I'm having right side and left side. So multiplied with the 2, which is equal to the net tensile force 300 into 10 cube into the load is up to here, the distance is 57.3. So if I'm going to solve this, I can get LW1 value. So 300 into 10 cube divided by 662.79 into 80 into 2. So the 2 is for so if we are going to calculate that, LW1 becomes 162.1 mm, say 165 mm. Therefore, LW2. So we have to substitute in this equation. Then, substitute in this equation so that we can get LW2. Okay. So LW1 value is 165 plus LW2 we have to calculate multiplied with 2 into 662.79. Alpha is equal to 300 into 10 cube. So while going to solve this, we can get the value of LW2 as 61.3 mm, say 65 mm. So this is the way we have to calculate. So LW1 each side. So here it is 165 mm and here it is 165 mm. Similarly, here LW2 is 65 mm and here also 65 mm. So that the total LW becomes 165 plus 65 into 2 times. So 460 mm is the total length of weld. Thank you.